not gonna fail this class. You got an A in here, don't you? All right. So then that's why we'll go over it. All right. So we have various limits here. So this one says, as the x value is going towards infinity, where are we approaching it for a y value? Not one, but as we go towards infinity, what is the y value we're approaching? Negative 1.
See, I'm confused. I don't know how to get the certain, what line it is. That's the part I don't understand.
Okay, there's only one line that goes towards infinity, and that's this one down here. This one goes between positive 3 and negative 1. This one goes from negative 1 all the way over to infinity. Okay? So it depends where you're at on the line. So this one, if they ask anything about going from negative infinity all the way up to negative 1, we're talking about that line. Anything in between negative 1 and 3, we're talking about that line, basically. Anything from 3 to infinity, we're talking about that line, basically.
From infinity to 2? Or wait.
3 to infinity. Okay, so what's the limit as x approaches negative infinity? The y value is 1 for that. Has a y value of 1. This one says, as x approaches negative 1 from the left. From the left. Which one are we talking about from the left? Are we, come on, computer. Are we talking about the green one or are we talking about the blue one? As we approach negative 1, and negative 1 is right here from the left.
Oh, that's the x. Okay.
As we approach negative 1 from the left, are we green or blue? We're green. Okay? So as we're going towards negative 1, what is the y value it's approaching? Positive 2. Okay? As we approach negative 1 from the right, what graph are we talking about? The blue one or the green one? As we approach negative 1 from the right, an x value of negative 1 from the right. The blue one, because an x value of negative 1 is right here. From the right means we're going this way. So what's the y value it approaches as we get close to negative 1? Negative 1. Okay, what graph are we talking about when x approaches 3 from the right? 3 from the left. 3 from the left is blue. And what's the x value it approaches? 3. And as we approach 3 from the right, the blackened in one, which is 1. You get that? We did this the first lesson, yeah. Okay. And we can do another one of those after a little while. Then the second part of the first lesson is we have 2x squared minus 3 and 5x squared plus 4. So when we have 2x squared plus 3 and 5x squared plus 4, as we go towards infinity, so we have x squared and x squared. When we have x squared and x squared, what do? They're the same, right? We can put x squared on the bottom of everything, but what does it end up to be? The coefficients of the highest power, which is just 2/5. It's just the answer. Of if the powers are the same. What if the powers aren't the same?
Then you do that thing that I just said.
Then you do the thingy that you just said.
But they are the same, so.
Yep. So that's only if they go towards infinity or negative infinity do you do that. Okay, so let's just write it the way Juliana explained it. So then you write 2x squared over x squared minus 3 over x squared over 5x squared over x squared plus 4 over x squared. So the x squareds cancel, and then it's 2 minus 3 over x squared over 5 plus 4 over x squared. Well, if you put infinity in for x squared, these become 0. So it's 2 minus 0 over 5 plus 0, which is 2/5. So that's only when we're doing the infinity ones do we look at the powers. Okay? If the power on the top is bigger, then it goes towards infinity. If the power on the bottom is bigger, then it goes towards 0. If the powers are the same, then it's the coefficients of the highest powers. Okay. Now what? Okay, this one, if we put 2 in here, it'll make the denominator 0, right? So what we have to do is we can't do anything else but graph it on the graphing calculator because there's no factoring we can do or anything like that. So we graph it on the graphing calculator. So it was, just a second, x plus 3 over x minus 2. So y equals, let's clear that out, x plus 3 over x minus 2. So, what does it say? It just says going to 2, right? So, if we look at the graph, oops, sorry. No. If we look at the graph, as we come from the left, whoa. Oh, quit. It was working. As we're coming from the left, you can see that it goes towards negative infinity. As we come from the right, it goes towards infinity. If it doesn't go towards the same place, then what do we do? The limit does not exist.
Wait, why?
Because it goes towards two different places. And if it goes towards two different places, the limit does not exist. The limit does not exist. The very last line of Mean Girls. Because this, from the right, it goes towards infinity. From the left, it goes towards negative infinity. So if a limit goes towards two different answers, then at that point, it does not exist. Now, if I said the limit as x approaches 2 from the left of x plus 3 over x minus 2, then be negative infinity. If I said limit as x approaches 2 from the right of x plus 3 over x minus 2, then the answer would be infinity. But since it just says towards 2, that means it's coming from both directions. Well, that does not exist because it goes toward negative infinity in one place and infinity in the other. Okay. Factor. So if we can factor, we factor.
4 plus, or x plus x minus 4 and plus 1
On the top, x and x, signs are the same. They're both negative. Factors of 4 are 1 and 4 that add up to negative 5. They cancel. That's what we have left. Now if we stick in a 4, we get 4 minus 1, which is 3. 4 plus 4, which is 8. The limit is 3/8. I'm not going to scroll.
So, but we can put that in our calculator, right?
Yep, you can do that on your graphing calculator, and you can find it. But the graphing calculator will say like 3.74444, 499, whatever. So you have to understand 0.375 is 3/8. Okay, so there will be a section where there will be a graph like that, and you have to find limits, and a section where limits that you'll have to do algebraically or on your graphing calculator to find the answer. And then you'll have to graph a couple problems. Here's a problem like what you might have to graph. Okay, and it'll also have blanks on it, which will say the vertical asymptote equals blank. Horizontal asymptote equals blank. X-intercept equals blank. Y-intercept equals blank. Okay? Vertical asymptote. You're correct. You get x squared minus 1 equals 0. Factor it. X plus 1 times x minus 1 equals 0. X plus 1 equals 0. X minus 1 equals 0. So x equals negative 1 and x equals 1. Now, when you write your answers in here, you need x equals on there. I'll take points off because it's a line, so it needs an equation. And it's not just a number. It's a line. Horizontal asymptote. Y equals 0 because the denominator has a higher power than the numerator. X-intercept. You set the numerator equal to 0. So it's 0.20. Then find the y-intercept, put 0 in for x. So it's 0, 6. So if we were graphing it, which you need to graph a sketch of it, I asked for a sketch of the graph. I expect your intercepts to be correct. So I expect 2, 0 and 0, 6 to be correctly graphed. Okay, you have an asymptote here, and an asymptote here, and an asymptote here. So since we don't have any x-intercepts in between here, you got to know that this goes like this. Got to be a parabola up like that. So if it's up here, then it must come from down here. Cross and stay close. So I would say this one doesn't cross and stay close. Now, I'm going to put it on my graphing calculator and check. 3x minus 6, x squared minus 1. And there's our graph. It goes down like this, never crosses the x-axis. Here it crosses the x-axis right at 2 and stays close to it. And then the parabola up over here on the top. Okay. And then the last section, find the area under the curve. That was our homework for today. Find the area under the curve for x squared plus 4 from 0 to 2.
I need to buy myself a little calculator for more. What?
Yeah, steal it, and we'll charge you $125 for it.
Would it be? Because I was definitely.
Volume discount?
Well, you need to charge it for that.
Yeah, but they say school property and all that on them, and so yeah. No, you buy your own.
I could just paint it. We could charge it.
Yeah. That's x squared plus 4?
No. My hands are right. That's what I have. You did subtract.
I did subtracting. And so you go second, trace, 7, 0 to 2.
10.7.
10.6 repeating. 10 and 2/3 is the actual answer.
Can I just round it though?
Nope, I'll count it wrong.
Why?
That's 10, because that's 10.7 is not correct. 10 and 2/3. 10 and 2/3 is the correct
Okay,
answer.
I'm gonna write every single number. All right, 10.66666. Why was it better than put it in the back? How am I supposed to know what the fraction is?
What?
What
Why not?
are you gonna put
Okay.
in the? I don't know fraction.
You can't drop the class anymore.
Give me a decimal and I'll put it into a fraction. Ready, go. You have to think about that one. Yeah, you did. Give me another one.
5/6.
Huh?
Actually, 4.
So is that all the test is gonna be?
That's what the test is going to be, yeah.
0.5555. I don't know. Yeah, see, I don't know that. What about 0.3? Wait, what?
3/8.
See, I don't know that.
We just did that.
Yeah.
What do that? I don't know.
You got to be able to convert fractions into decimals or decimals into fractions.
Well, I don't need that to be a nurse.
Yeah, you do.
No, I don't.
Yeah, you do.
No.
So if you need to put 0.2 milliliters of solution into a syringe and it's marked in fractions instead of instead of tenths, it's marked in fractions of 1/4. What is it? Where would you go?
Point what?
You have to put 0.2. Okay, so you have a syringe. You have a syringe. Here it is. I'll even put it kind of 3D-ish for you. Help you out. So this is 0.25 milliliters. Wait, this is, geez, I just screwed up.
1/4.
This is 1/4 milliliters. This
Then
is
I
1/2.
just put on my calculator and do it.
This is 3/4. This is 1.
0.5.
Okay? If you were supposed to put a dose of 0.2 milliliters in there, where would you go?
I would ask Alexa how many milliliters.
Honestly,
What
wait, no, 0.2. It'd be in front of it'd be on one of the lines in front of the 1/4.
It'd be right here, right?
Yeah.
So if you were told to put in 0.8, where would it be?
It'd be behind the 34.
Yeah, okay, so that's,
See, like
You gotta have
those
some-
are easy, but like 0.576, like no.
0.576, no.
What?
You just keep a calculator in your brush.
That's what I'm gonna do.
Okay, I gotta go scan these,
Handy dandy.
and then I'll come back to you guys.
Are
So,
we done for today?
you know what? I'm still recording, so.
Well, wait, why
Poor
are you
Eleni.
recording?
For Eleni.